Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. When a primary aliphatic amine undergoes deamination, diazotization followed by loss of N2 with nano to HCl, the diazonium ion formed is unstable and generates a carbocation intermediate. This carbocation can undergo various reactions including elimination to give alkenes as well as rearrangement. Moving on to the next step. Identify the substrate. N-BU-NH2 is N-butylamine. CH3CH to CH to CH2NH2, a primary amine with the amino group at C1. Moving on to the next step. Reaction mechanism. Treatment with nano to HCl generates the diazonium salt CH3CH to CH to CH2N2+, which rapidly loses N2 to form the primary carbocation CH3CH to CH to CH2+, 1-butyl carbocation. And for the final step, carbocation rearrangement. The primary carbocation at C1 can rearrange via 1,2-hydride shift to give the more stable secondary carbocation at C2, CH3CH2 plus CHCH3. Elimination from C1 carbocation, 1-butyl cation. Loss of a proton from C2 gives 1-butene, CH2 is equal to CHCH to CH3. Elimination from C2 carbocation, 2-butyl cation. Loss of a proton from C1 gives 1-butene, same as above, loss of a proton from C3 gives 2-butene. 2-butene exists as CIS and trans isomers, giving CIS, 2-butene and trans, 2-butene. 1,1-butene, CH2 is equal to CHCH to CH3. 2 CIS, 2-butene. 3 trans, 2-butene. These are 3 isomeric butenes accessible from the carbocation intermediates generated during deamination of N-butylamine. Why other options fail? Option A, 2 undercounts because it ignores the CIS trans distinction of 2-butene. Option C, 4 and D, 5, overcount isobutylene to methylpropene would require a methyl shift to give a branched skeleton, which is less favored under these conditions and is not counted as a butene isomer in the standard treatment of this reaction for this context. Therefore, the correct answer is B. Therefore, the correct answer is option B.